everyone, this is Ramalinga Prasad Kupa. Welcome to my channel, Pharma World. Today's topic is equipment qualification for plant and QC areas, the basic understanding. Plant equipment include but not limited to reactors, centrifuges, dryers, distillation setups, etc. Laboratory equipment include but not limited to HPLC, GC, IR, UV, etc. This list also includes equipment used for wet analysis like Qualification titrator, melting point apparatus, conductivity meter, hot air ovens, bulk density apparatus, etc. to name a few. The purpose of this video is not really an insight into the detailed qualification. The intent is only to make the beginners understand the basic concepts. Let us move forward. What is qualification? By simple definition, qualification is evaluation against a set of acceptance criteria and confirm for compliance. For example, you are a pharmacy graduate. That means you are qualified to be a person who passed to the syllabus of pharmacy. Syllabus is set of requirements and based on which there will be a challenge test as an examination and you have to pass to get qualified. Then you get a certificate of compliance. This is as simple as this. Same concept is valid for any requirement also. Basic criteria for equipment qualification focuses on the usage principle of the equipment. The qualification starts with usage requirements of equipment. It should pass to the design requirements, installation requirements, operation requirements, and performance requirements. For example, if you want to make an adventurous trip across the country, you don't select a small motorcycle. Probably you need an SUV with adequate storage space and be able to move safely in any terrain with ease. All these aspects come under total qualification for equipment, is it not? Qualification requirements vary widely for all equipments depending upon their working principle. Obviously, each equipment has its own purpose and working principle. Probably no two types of equipment will have same specifications. Many of the laboratory equipment will have more micro level or nano level specifications. Most of the sensitive equipments in laboratory will have micro level or even nano level accurate specifications. The list includes HPLC, GC, UV, IR, etc. The requirements are more and also will be elaborate. Let us see the qualification requirements of plant equipment, typically a reactor. Volume. This is the first requirement. How do you decide on volume requirement? It depends on two factors. One is the input quantity, another is the output quantity. The reactor volume should be suitable to process the reaction among the ingredients and finally get required output. It is a general thumb rule to use the equipment in the range of 50 to 80% of the volume. Agitator. Selection of agitator depends on the type of material to be processed. Agitator selection depends on the type of mixing pattern of the materials inside the reactor. Anchor type of agitator is used to mix heterogeneous mixing of materials. The swing span of the anchor type is much more. Certain highly viscous materials are mixed using a propeller type of agitator. When propeller type of agitator is used, the position of the agitator will be off center of the reactor. This is to avoid vortex formation in the reactor. If there is vortex, the mixing will not be uniform. For some wet granulation, there will be planetary movement of the agitator. That means the agitator rotates itself around and rotates around the center. Something like Earth moving around the Sun. See the complexity of the requirement. Jacket type and volume, cooling and heating cycles decide the selection of jacket type and volume. There are plain jackets, coiled jackets, mostly used in pharmaceutical API manufacturing. The plain jackets are generally used for slow heating or cooling. The coiled jacket is suitable for faster operations. The coiled jacket also provides structural rigidity for high temperature operations at high velocity and turbulence. The volume depends upon the type of coolant used and the type of cooling system used and the rate of heating and cooling. Other items include material of construction of equipment, baffles, gearbox for the agitator shaft, RPM of the agitator, type of input valves and output valves, smoothness of the inner contact surfaces, etc. to name a few. Material of construction, MOC, depends totally on the type of reaction inside the equipment. Highly acidic reactions can be carried out in glass-lined reactors. Stainless steel reactors may not be suitable for such acidic reactions. Similarly, highly alkaline reactions are conducted in stainless steel reactors. Baffles are used for uniform mixing of the material inside the reactor without vortex. Gearbox will take care of the agitator rotation smoothly. It should be adequately designed for the purpose. It's also necessary to see that there is no leak of lubricants into the reaction mass through the agitator shaft. Revolutions per minute, that is RPM, is decided as per the process requirement. Types of valves used, the smoothness of the contact surface of the reactor have also to be focused while designing the reactors. See how much syllabus is prescribed for a reactor. So it is necessary to look into all these minute items for designing for qualifying the reactor. Let us see typical requirements for centrifuge qualification. There are several types of centrifuges for solid liquid separations. Another example is a centrifuge. The types include a simple notch filter to a sophisticated agitated notch filter, high-speed centrifuge, etc. The selection of filtration system totally depends on the type of the product. If the material is crystalline in nature and easily filterable, a notch filter is very useful. By applying vacuum, the separation could be achieved well. For handling of huge volumes and faster operations and unloading the wet cake faster, agitated notch filters, that is ANFs, are very useful. Volume depends on the design output of the product. Selection of size of filtration system totally depends on the product volume turnout. Variable frequency drive VFD is necessary if the centrifuge needs to be operated at different RPM. This depends on the product characteristics. For some products, the major mother liquor can be expelled easily at low RPM. But at the end, the mother liquor in close contact with the product takes more time to expel. In such cases, the speed of the centrifuge has to be increased to expel out the remnants. For such operations, the VFD works well. Fixing, grouting is very critical for such centrifuges. This is very important. If the centrifuge is not grouted on the floor firmly and horizontally, it can wobble at high speed and damage very badly. Worst case, it can be pulled off the ground. This care must be taken for centrifuges. You need a firm ground for such centrifuges. That's why you see all high-speed centrifuges are installed in the ground floor with adequate working space nearer to the reactor bottom valve. Filter bag porosity depends on the particle size of the product. The notch filter or centrifuge design is incomplete without the filter bag dressing inside. The porosity of the filter bag will be 5 microns or 10 microns or any other suitable size is required. Mostly a polypropylene non-reactive type filter bags are used. It is important to get the certificate of compliance for porosity of the filter bag from the supplier. As in the case of reactor, all these design aspects have to be captured for qualifying the centrifuge equipment. Let us see what kind of specifications are required for qualifying a dryer, a mill, a pulverizer, and a sifter. These are other important equipment necessary for pharmaceutical manufacturing. The other major equipment used for pharmaceuticals include dryer, mill, pulverizer, sifter, etc. Tray dryers, vacuum tray dryers, rotocon vacuum dryers, RVD, etc. are generally used. Dryer selection is done based on the characteristics of the product being handled. If the product is crystalline, stable and remnant solvent can be removed easily, a simple tray dryer may be selected. Again, the size and number of trays, type of trays depends on the product output and characteristics. If the wetness of the cake is more, vacuum tray dryer may be selected. There is an advantage on the vacuum tray dryer. It can help remove the residual solvent faster and at lower temperature range. If the product is sensitive to the drying temperature, it is always recommended to use a vacuum tray dryer. Rotocon dryers are selected for any product that is sensitive to the presence of atmospheric air, which can deteriorate the product. Also, when the water content in the product has to be maintained with a specific range of wetness or water content in the product, Rotocon vacuum dryers are best selected. Mill is used for size reduction. On general terminology, a mill is used for size reduction or delumping. The design is not suitable for milling a smaller sized particles. Pulverizer is used for milling the product to lower micron level size. The pulverizer is designed to reduce the particle size into micron level to submicron levels. Though speaking technically, both are size reduction equipment, it is a general terminology to use two different terminologies for mill and pulverizer. Sifter is used to get required range of particle size product as per the customer requirement. Sifter is selected for grading the product's particle size. It is available with different mesh grades as required. You have 10 mesh, 20 number mesh or 40 number mesh or 60 number mesh or 100 number mesh, to name a few. For exact details of mesh number, mesh aperture size, you may refer USP chapter 786. You get more details. So according to the exact requirement, the qualification should focus on necessary specifications. Let us see the qualification requirements of QC equipment, a typical HPLC equipment. The main components of HPLC include pump, injector, detector, tubing, etc. Pump should be able to work at high pressures of around 600 psi and flow rate of 0.2 ml to 10 ml. It is also important that the flow should be maintained uniformly for several hours, as the analysis may run for longer hours ranging from few hours to almost 24 hours. So the selection of pump should have all these characteristics. Of course, the equipment supplier provides you such pump in the HPLC system, but it is necessary to know this fact. You have to qualify this aspect. Injectors are two types basically. One, the earlier models of HPLC almost dated 5 decades ago. The injection volume used to be measured by external airtight syringe and injected into the system for analysis. Later to that, the invention of Rheodyne type of injector made the chromatographer life easier. It has accurate and reproducible fixed loops like 5 microliters, 10 microliters, 20 microliters, etc. You don't have to worry about varying peak areas as in the case of directly measured injections. See and understand the design of Rheodyne injector. It is really wonderful design. Check the path on how the loops are designed while in load position and in inject position. Really very interesting. Detector is really the heart of the system. It should have adequate intensity and required wavelength. The wavelength should cover the majority of UV range and visible range. As you know, many analyses are being carried out in UV range. The intensity of the detector lamp should be stronger in the UV range than the visible range. However, generally all HPLC detector lamps cover the UV and visible range. The range should be between 190 nanometers to 700 nanometers. The qualification should focus on this for compliance. Tubing is another important aspect. The size of the tubing between the column outlet and the detector inlet is critical. It should not be too long. Make a requirement in the design that the bends in the transfer tubing be minimum and no damages to the tubing. Damaged tubing can impact the analysis. Never make a 90-degree angle for the tubing. It restricts the flow because of constriction. This is all about the hardware part of the system. More important aspects are the software for running the analysis. How to run the system for successful analysis? It is the software that takes care. Most importantly, the software should be capable of checking the data integrity. It means that the audit trail should always be active. By definition, audit trail is construction of event by the time and the person. Don't get confused with the word trial, which is spelled as TRIAL. This is trail, TRAIL. Access controls, peak integration types, data capture, all have to be meticulously done in the qualification of the system. That is the difference and elaborate subject which has to be discussed separately. Preventive maintenance, calibrations, though they are part of the routine job to carry out, there should be clear provision in the qualification report on the frequency of preventive maintenance and calibrations. We make provision for routine preventive maintenance and calibrations as scheduled. This should be a part of qualification conclusions to keep up the working status of the equipment in good condition. Let us see the requirements for qualifying a gas chromatograph. The main components of GC include oven, injector, detectors, associated pressure gauges, tubing for carrier gas, hydrogen, and air. The main component oven should have provision to fix capillary columns of various dimensions and packed columns. The operating temperature should be between ambient to 450 degrees Celsius. Ramp rate should be between 60 degrees and 80 degrees Celsius. The cooling pattern should also be faster. The oven should be cooled down to ambient temperature within 5 minutes. The inlet tubing should be fitted with silica gel tubes to make the gases free from moisture. The silica gel should be coarse, self-indicating crystals. Even aluminum oxide pellets or molecular sieves may also be used, but they are not self-indicative. You may have to regenerate after some time to make it active again. All these aspects also should be part of your qualification report. The type of injector depends on the requirement. Manual injectors may be cumbersome and time-taking for series of injections simultaneously. Analysis includes 5 or 6 system suitability injections, couple of blank injections, duplicate sample injections, making it too many. Manual injections may not be accurate and can yield erroneous outputs. So the auto sampler or auto injector should be qualified for reproducible injection capability and a wash sequence after each injection. If there is a requirement to have FID and ECD, there should be a provision for such additional adapters for interchangeability. Suitable pressure gauges for giving uniform flow rate of the gases should be selected and qualified for the expected range for packed columns and capillary columns. Similar kind of software used in the HPLC system is necessary to run the analysis with active audit trail facility. Same strategy as in HPLC holds good here too. Since the outlet of FID has exhaust gases, it is recommended to qualify the exhaust system above the detector system. Since the GC generates heat, it is recommended to qualify the air conditioning system to work efficiently to maintain the equipment well. These 2 points are also important to qualify a gas chromatograph. Let us see the qualification requirements of UV, IR and other types of equipment. Similar approach on qualification of other electronic equipment including UV, IR, auto titrator, particle size analyzer, etc. Other equipment like UV, IR or any other electronic equipment should be qualified for its actual working requirements. The output intensity of UV lamp should be certified and qualified. The wavelength accuracy should also be taken into consideration. The IR range, wave number tolerance or resolution accuracy should be plus or minus 1 or 2 cm minus. Polystyrene film used should have a valid certificate. Thickness should be around 35 microns. The radiation pathways of IR should be clear and never opaque. Because of its nature, the grating and cells will be sensitive to the presence of moisture in the surrounding and may become opaque if not handled carefully. This should be focus part of the qualification. Delivery volume accuracy will be important in auto titrator qualification. Particle size analyzer should be qualified for the range of particle size determination and requirements for wet dispersion technique and dry dispersing system should also be qualified. Other equipment include but not limited to Carl-Fisher titrator. Carl-Fisher titrator should have burette with 0.05 ml least count. This is a requirement to qualify the KF apparatus. If electronic burette is used, volume delivery should be qualified for accuracy up to 0.05 ml or lower. The potentiometer should be qualified for the correct endpoint of the KF titration. Melting point apparatus All the intricate points of USP Chapter 741 should be addressed and qualified for compliance. The parameters include rate of heating, selection of heating medium, selection of standards to meet the required range, etc. Bulk density apparatus. Bulk density apparatus should be qualified as per USP Chapter 616. There are several important points. They include the qualification of measuring cylinder also. There are definite specifications for the weight of the cylinder to be used and the number of taps. You cannot use any measuring cylinder as you wish. It should be a qualified cylinder. Usage of 1 mm mesh is also a specific requirement for the test. All these items have to be qualified to carry out the bulk density test accurately and scientifically. Conductivity meter, pH meter. Conductivity meter should be qualified for the range required. The cell constant is different for different conductivity ranges. This is critical for conductivity meter qualification. Necessary parameters for pH meter. In this also qualification of calomel cell is necessary. Potentiometer, etc. Similar requirements for potentiometer should also be qualified. The important points to note are: qualification is a two-part evidence. First part is the protocol. Protocol is a procedure for a specific purpose for a specific period. The protocol should describe all the intricate steps to carry out the verification of the design, installation, operation and performance qualification of the equipment. Protocol is different from an SOP, though the protocol also describes a procedure to execute. This is a specific document for a specific purpose and for a specific time period. Second part is the report. The report should be exact execution as prescribed in the protocol. The data should be numerical, signed off at appropriate stages of qualification. The report should have objective evidences attached for all appropriate stages of qualification. A sign-off for prepared by, reviewed by and approved by should be the part of both protocol and report. I hope that the intent of qualification and intricate points to focus are explained well in this video. It is important to understand the purpose of the qualification. Thanks for watching. For more videos, please do subscribe, like and share. Thank you.